Okay, that is the our slide, the sheet, what we are discussing so far. In the previous class, I have discussed some energy and power of continuous signal, right? Periodic, aperiodic signal. We have discussed these things, periodic and aperiodic signals, and today we'll discuss about the energy and power signal. Okay, energy and power of continuous time signal. We'll study this thing. Okay, and energy and power of continuous time signal. Okay, have you seen the previous things at your home? I think you should check. Okay, at your free time you should check the thing. Okay, so that you get some idea. Today we'll start the thing that okay, see what is the energy and power. See the circuit diagram. See this one. See the circuit diagram. Few guys are trying to join still. Okay, energy and power of CD signal, that means continuous time signal. Okay, if we look at this circuit, say what is the Ohm's law? V is equal to IR. V is equal to IR. We know that this is the Ohm's law. And what is the power equation? I square R. We know V equal to IR. V equal to IR. And the power equation is the I square R. Okay. I square R. I square R. Here you do one thing. I into IR. So we can write that I square R. We can write that I into IR. I into IR. We can write that. Okay, I into IR. And V is equal to IR, right? So if we write like this, IR into IR, then we should divide it by R. So we can write the V square by R. See what they said. Ohm's law is equal to V equal to IR, and power equation PT is equal to I square R. That means V square by R. Okay, here we can write this. Write like this. Okay. Now, if R is equal to 1 ohm, then what would happen? P is equal to I square T or the V square T. So we can say that PT is equal to X square T or instantaneous power. PT is equal to instantaneous power. PT is equal to instantaneous power. Okay. PT is equal to X square. So we can say that PT is equal to X square. So PT is equal to instantaneous power. So P is equal to what? Work by time, W by T. P is equal to W by T. P is equal to W by T. And see here. P is, W is equal to PT. So W is equal to what? W is equal to PT. stores as energy, so is equal to PT. Now look at here, total energy. Total energy is the E. Minus infinity to plus infinity is equal to PT into dt, or minus infinity to infinity x square t dt. That is the total energy. Minus infinity to infinity pt into dt is equal to minus infinity to infinity x square t dt. Okay, because instead of pt we can write the x square t. And average power, what would be the average power? Limit t times to infinity 1 by t minus t by 2 is equal to the t by 2 pt dt. Now instead of pt we can write the x square t dt. Okay, so these are the equations for, or we can write like this, 0 to t naught. Okay, 0 to t naught, average, for average 1 by t naught, if we consider it is the t naught. See, that is for the non-periodic signal and that is for the periodic signal. Okay, two difference. For the non-periodic you have to start from the minus t by 2 to the t by 2, and for the periodic 0 to t naught is equal to 0 to t naught. Okay, for periodic signal, the non-periodic and the periodic signal. And see this. So these equations are required. Now, what is the energy signal? The signal whose energy is finite but average power is 0 is called the energy signal. And the signal whose energy is finite but average power is 0 is called energy signal. So it is 0 to infinity. So Ex, P average is equal to 0. Power signal. The signal whose energy is infinite but average power is finite called the power signal. So it is, the range is 0 to infinity. So that is, the energy is infinite. So see, now see the definition again. The signal whose energy is finite but the average power is 0 is called the energy signal. Okay. So energy, what is the energy signal? The signal whose energy is finite. Energy is finite. So 0 to infinity. Okay. So energy is finite but average power is 0 is called the energy signal. Okay. Average power is 0. That is the energy signal. So remember these equations, these conditions. What conditions are there? Like 0 to infinity and P average 0. Okay. And the power signal. What is the power signal? The signal whose energy is infinite but average power is finite is called the power signal. So that is 0 to infinity or energy infinite. So that is the conditions. 0 to infinity, P average, and energy is infinite. Okay. Power signal. The signal whose energy is infinite but average power is finite is called the power signal. Now another one is there, neither energy nor power signal. Neither energy nor power signal. The signal whose energy and average power both are infinite is called neither energy nor power signal. Okay, neither energy nor power signal is there. NENP. Neither energy nor power signal. NENP. Okay. So three kind of signals are there. Say energy signal, power signal, neither energy nor power signal. Now calculations, some calculations. Calculate the energy of the following signal. Now you have to calculate the energy of the following signal. A signal is there where A is greater than 0. Now what you will do? Minus infinity, we know that energy signal is of minus infinity to infinity x1 t whole square dt. So instead of x1, put this value, put this value, multiply it, then what you would see? Minus 1 by twice a, okay, in the outside, minus infinity to infinity. Since it is greater than 0, so that is 0 to infinity. So 0 to infinity. So minus 1 by twice a, e to the minus infinity minus e to the 0 is equal to 1. So minus 1 will be plus. So it is the plus. Is e is equal to 1 by twice a. That is the final value. So this signal is energy signal. Since it is finite. Since it is finite, so the signal is energy signal. The signal is energy signal. See. And another example. Now try to understand this again. Now calculate the energy of the following signal. Calculate the energy of the following signal. Okay. So what would you understand from this example that? So first of all, we have to follow the main equation. Just look at here. See this equation. Total energy minus infinity to infinity xt square dt. Just put this value here. Minus infinity to infinity x1 t square dt minus infinity to infinity e to the minus 80 ut square dt. Now put this value. Since we know that a is greater than 0, so it would be 0 to infinity. Do the calculation, then you'll get this one better. Since if you put any value of a, then you'll get the value of e. So it is finite. So this signal is energy signal. The signal is energy signal, finite. Okay. So if the condition lies below, if it becomes infinite, then it would be power signal. Since since the signal has some finite value, so it is an energy signal. Now our second example, x2t is equal to e to the power minus 80 ut, where a is less than 0. So is less than 0. So this kind of figure would be there. Oh, in the previous see that is the signal, that is the x1t, because a is greater than 0. Okay, that is this kind of signal would be a. Now the second one, the signal is rising. The signal is rising where a is less than 0. A is less than 0. So value would be here. The signal is rising, so energy is infinite. So infinite because signal is rising. This kind of signal ut. Since ut, so it could be like this. Okay. Another example. Look at the another one. x3 is equal to e to the power minus 80 ut, where a is equal to 0 and x3 is equal to ut. So energy is infinite. Why energy is infinite? Because the area is infinite. is equal to 0 to like this. No effect of time reversal, no effect of time shifting, no effect of amplitude shifting, no amplitude reverse. So that's why there is a reversing. Now look at the another example. x3 t is equal to x1 t plus x1 minus t. So 1 by twice say, plus 1 by twice say. No effect of time reverse of time. So is equal to 1 by a. Okay. So x3. Okay. So if we look at another example here, x of 40, the range is -4 to 4, 0, 2, 4, 6, 8. These are the values. Now if we look at the equation, energy signal, at first 0 to 2, 0 to 2, minus 4 square dt, plus 2 to 4, positive 4, plus 4 to 6, negative 4, negative 4, plus 6 to 8, positive 4 dt. Okay. Now 0 to 2, 16 t square, integration of dt is t. Okay. Like this. Okay, like this, do the calculation and we will get the value. That is definitely a finite value. So this is energy signal. Okay, so this is energy signal because this is the value becomes finite. Okay. Okay, so this kind of signals you can do the calculation like this. For this kind of signal you can do the calculation like this. Okay. Now time scaling. What is the time scaling? See, x t is equal to e, so x at is e by a, and amplitude scaling e ax t. Okay, so remember this formula. Remember the formula, time scaling as well as the amplitude scaling. Time scaling x t is equal to e, and if x of at e by a, and amplitude scaling x t is equal to e a of x t a square e. Okay, so these two things, time scaling as well as the amplitude scaling. So see, for the time scaling, the value would come in front of t, and for the amplitude scaling, it would come in front of the signal itself. So find the average power of the x1 t is equal to a naught sin omega t. Find RMS value also. Find RMS value also. Find the average power of x1 t is equal to a naught sin omega t, and find RMS value also. See, that is the problem. Find the average power of x1 t. So a equation is given, and also the RMS value. You have to find out the RMS value. Okay. So here is the average power. So average power 1 by t naught, 0 to t naught, a naught sin omega t square dt. So sin square omega t dt. So sin is, so instead of sin square, we can write the 1 minus cos 2 omega t divided by 2. That is the trigonometric equation C. 2 sin square omega t 1 minus cos 2 omega t. Okay, so sin square omega t what? 1 minus cos 2 omega t divided by 2. So put this value here, put this value here, and do some calculations half. Okay, so 0 to t naught, half would come here, and minus 0 to t naught cos 2 omega t dt. Okay, it would become 0 if you do the calculation. With this thing, 2 will be come forward. 2 will just take the common, half common, and it will come forward. Only this thing would be there. So instead of t, we can write this, and a naught square by 2 t naught, t naught would be cancelled out. So a square by 2, a naught square by 2 would be there. So what is the RMS value? Square root of p average. So that is the RMS value, root mean square value. Okay, root mean square value is square root of p average. A naught square divided by 2. A naught divided by square root of 2. Okay, so that is the average power of x1t, a naught sin omega t. Find RMS value also. Okay, so this is the solution of this kind of problem. Okay, this kind of problem. So you need to know the trigonometric equations. You need to know the trigonometric equations. Okay. Okay, now find the average power and RMS of xt. Find the average power and RMS of the xt. Another example is there. For this equation, you also let me check. Okay, we'll see up to this. We'll see up to this today. Okay, so find another example. Find the average power and RMS of xt. Average power and RMS of the xt. So see this kind of equations. Figure is given. So limit t tends to infinity 1 by t minus t by 2 to the t by 2 x of t whole square dt. That is the non-periodic signal. These equations for the non-periodic signal. Now 1 by t minus t by 2 0 minus t by 2 0 and 0 to t by 2, that is 0, and here the value is a square because x square, so a square. So only this value remains. So just do the calculation, a square of t naught or the a square by t. So RMS value will be this. So this has no effect on time scaling, time shifting, time reversal, amplitude reversal, amplitude shifting, amplitude scaling. So x is equal to p, k of xt, k square p. Okay. So that is the solution of this equation. Find the average power and RMS value of the xt. See. So you can find the value here. This kind of equations. Now another one. If the energy of xt is 4 joule, find the total energy of yt 2jx 2t minus 1. See, if the energy of the xt is 4 joule, see, so here yt is equal to 2j into x of 2t minus 1. So energy signal 2j square into 4 by 2. 4 joule, right? 4 joule. It is 4 joule. 2j into x into 2t into 4 by 2, just it would be 4j square, 4 minus 1. Say x is equal to 4, x of 2t, 4 by 2, x of 2t minus 1, 4 by 2. Okay, so x of 2t, okay, do remember one thing, what we have seen before. See, time scaling, xte and x of a t e by modulus of a. Amplitude scaling, x of t is equal to e and axt in a square e. Okay, since it is time scaling, so 4 by 2 because it is 4 joule, x is equal to 4, so 2t divided by 2. Okay, and minus 1 is also 2 by 2. So put this, so this thing 2 square means what? 2 square means 4. J square means minus 1. So minus 4. So it would be 4 and it will be 2. So 8 joule. So it would be the 8 joule. If the energy of the xt is 4 joules, so find the total energy of the yt is equal to 2j x into 2t minus 1. Okay. If the power of xt is 8 watt ampere hour, find the power of yt is equal to 7x t minus 1 plus 4. See, that is your the equation. The yt, so power is equal to 7 square, definitely it would be square t minus 1 into plus 4, 4. So 8 watt per hour. So 4 into 8, okay. Xt is equal to 8. So xt is equal to 8. So xt minus 1, it is also 8. T minus 1 plus 4, it is also, it would be also 8. Okay, like this. So these problems are not very important, but rather we have to check this kind of problems. Okay, now let's look at the another thing, some basic signals. Look at some basic signals like the, we need to know some basic signals like this. So what is the unit impulse signals? Okay, what is the unit step signal? What is the ramp signal? What is the orthogonal signal, parabolic signal, and the signum function, the unit regenerator functions, unit triangular functions. Okay, we need to know these things. Okay, let us discuss some because we have some time still. We have some time. Okay, so unit impulse signal. See the unit impulse signal. This kind of signal is the impulse signal, unit impulse signal. Delta t 0, 1. 1 is this and 0 otherwise. Okay, when the x is t is equal to 0, when the t is equal to 0, then the delta t is equal to 1. When the otherwise, when the t value is other than 0, then it is 0. The value of this impulse signal is 0. This kind of signal is known as the unit impulse signal. Okay, this kind of signal is known as the unit impulse signal. Okay, unit impulse signal. And the unit impulse signal is like this. It would be like this. Okay, 0 to t, 0 to t, 0 to 1. 0 to t is equal to 1. Look at the signal type. What kind of signal it is? When the t is greater than or equal to 0, the amplitude value or the ut value is the 1. When the t is less than 0, then it is 0. Okay, that's the thing. And the ramp signal, look at the ramp signal. Look at the ramp signal. This kind of signal is the ramp signal. See the signal type. Okay, see the signal type. Uh, so when it is at this position, the value is 1, amplitude is 1, and the value of the t is also 1. Okay, so this kind of signal. So it t, the rt is equal to t when t is greater than or equal to 0. It is t when the it is 0 when the is less than 0. Okay, another kind of signals are there, that is the orthogonal signal. Two signals are said to be orthogonal if they are mutually independent. Okay, if they are independent, they are orthogonal. And parabolic signal, This kind of signal is called parabolic signal. So when the t is greater than 0 or equal to greater than 0, then it is the t square by 2. When the t is less than 0, it is 0. And signum function, also known as the sine function, SIGN, sine function, that is called a signum function. So SGN, it represents as SGN. -1 when t is equal to less than 0, when the t is equal to less than 0, -1, and when t is greater than 0, it is 1, but when t is equal to 0, it is 0. When the t is equal to 0, it is 0. This kind of signal is known as the signum function. This kind of t equal to 0, discontinuity, so no differentiation at t is equal to 0. This kind of function is called the signum function. Okay, this kind of signal is called the function. And unit rectangular function, also known as gate function. Just a minute. Okay, and unit rectangular function, look at the unit rectangular function, also known as the gate function. Okay. Now see, when the value RECT, rectangular function, is also known as the gate function. It is also known as the gate function. Minus a by 2, 1 by a. It is 0. When t is less than minus a by 2, it is 0. When the t is greater than a by 2, it is 0. But in between, it is 1 by a. In between, it is 1 over a. That is the rectangular function. And unit triangular function, this kind of function is called the unit triangular function. T plus 1 when it is the -1 to 0, it is t plus 1. When the 0 to 1, it is minus t plus 1. Okay. And sinc function, DSP information theory. Okay, two types. Sinc functions, two types. Normalized sinc function and unnormalized sinc function. Okay. And see this. Unnormalized sinc function, sinc t 1, t is equal to 0. When t is equal to 0, it is 1. And when t is not equal to 0, it is sin t by t. And this is unnormalized. And when the normalize, it is 1 is equal to t equal to 0. And it is not sin pi t divided by pi t. See the signal. It happens when it is not 0. Okay. The magnitude is 0 at integers value of time. See, integers value of time is magnitude is 0. Remember this. Here magnitude is not 0 at the integer time value, but here the magnitudes would be 0 in that case. Okay. So today I think that is enough. Okay, we have discussed many things like various kind of signals. We have discussed some basic signals as well as energy and power signal examples. Okay, we have discussed these things. So you should look at these things at your at home. Okay. So energy and power signal, we have started today from the energy and power signal. from the energy and power signal. We have started. Okay, energy and power of continuous time signal, Ohm's low power signal. We have seen the circuit diagram. Okay, these things. Total energy minus infinity, minus infinity. Okay, these things. Non-periodic signal as well as the periodic signals. Okay, we have seen this thing, and we have seen the energy signal, we have seen the power signal, and these and after that neither energy nor power signal. We have discussed this about this thing, and we have seen some examples as well. Okay, some examples are there. We have discussed about it. Okay, energy and average percent as well as the RMS value. Okay, and we have seen some basic signals like unit impulse signal, unit step signal, ramp signal, orthogonal signal, parabolic signal, signal function, unit rectangular function, unit triangular function, sinc function, and unnormalizing function as well as the normalizing functions. Okay, from the next we'll start the system. Okay, so I think I stop the sharing today. Okay, these things we have discussed. Okay, just check at your home. Okay, guys, and let me check the attendance. Since it is online class, it is not possible to take your views. But if it is not the online class, then I can give you the problem. You can check. You can do it in front of me. Then I can check. Okay, but it is not possible here. Okay, so that's why I have to complete the class in this way. So it is almost impossible for us. Okay, this is 2920. 2920, day 28. I think I have given you the soft copy, right? The soft copy of the lecture sheet.
It's already.
Yeah, it's already uploaded. Okay, let me check the roll number here. Let me check. Yeah.
Yes, sir.
Roll number?
14, sir. 14.
14.
Yes, sir.
Sanjida there, Mithun there, Ibrahim there, 12, 18 to 10. Okay, 14, 1, 6, 9, 12, 18 to 10.
Yes, sir.
Anyone there previously? Your any friend missing?
14.
Yeah.
No, sir. No.
No. Okay. So I'm closing this one. Okay.
Hello, sir.
Yes, please.
Sir, ক্লাসের এগুলো ভিডিও দিবেন না?
ও আচ্ছা, হ্যাঁ ভিডিও দিব, তারপর নেটের সমস্যা করতেছে তো আপলোড হয় না। ঠিক আছে, দেখি এটা কি করা যায়।
দুটো দিলে একটু ভালো হয় আর কি।
হ্যাঁ বুঝছি আমি। ঠিক আছে, দেখি আজকে দিয়ে ট্রাই করবো আমি।